Okay, this is a video I wanted to put together. It's a bunch of little things that were hanging around, and I thought that I'd get to them. So it's kind of a potpourri mishmash here. So I want to start out with this one. I thought this was kind of neat. This is a duck knife, which I think are a pretty good Chinese knife or whatever. And it's got some sort of fiber handle. It's got a thin liner. It's got a thicker sort of liner handle to it. And it seems to be an assisted opener. So when you close it up, it's got a lock here. Push it up and it's locked. The only problem is if you unlock it, it flies open. So it's got some sort of problem with the assist mechanism that I am very curious to look at. So I'm going to pull it apart and find out. By the way, this is a spring from another assist knife that I tore apart a while ago and never got back together. So you can see, it's, if you're familiar with the Ken Onion design of the Speed Safe, it looks quite a bit different. So I'd like to see what's up with this spring and why it's not working. Okay, so this is not like the Speed Safe. Actually, it's more like this one here. And this is the actuating spring. Okay. This is from a little bit bigger knife. So this is a little bit bigger, but same idea. This has got 2 loops here and 2 loops here. And this one comes halfway down. So this has got more loops in the spring, but they both have hooks that go in to the blade. So here is the arcuate groove or arcuate slot that the tip of the spring will travel in. And the whole idea is this is putting pressure to bias the blade to turn, but it should be putting a vector of bias above the pivot pin in the closed position, and then once you get it rotated about 30 degrees, the vector is going to change from above the pivot pin to below and then fly the blade open. And it flies the blade open real nice, except it won't stay in a stable position. And it is a basically, I guess, a frame lock on this side. And here is the cutout for the spring, and this flat section of, I don't know if that's wood or not. I don't think it's wood. Yeah, maybe it is wood. Pretty high class. All right, we got a wood handle. That's what it pushes against. In fact, I could even make it bend a little bit there. Not much. These things are stiff. So the remedy to fix this, I don't know, maybe bend the spring so the vector is a little more down. I could see that both of these springs have a little bend right at the end here. So it comes, this one actually has a little bend here, and then a little slight bend there, and then the hook goes up. This one's more straight, but then it has a bend this way, and then the hook goes up. So I might just tinker with this for our own education here to see if it's something that's fixable. It could be that, and I assume that a lot of these have come out of the factory working well, so maybe this thing was used quite a bit, although it's really basically brand new. I got this from a knife dealer that was a return. So I think it was not working properly either right away or never did. He never sold it and just threw it in his junk box, and that's when I came in with my curiosity. Maybe I'll take a pair of pliers and bend it, but that's about the only thing I could think to do is change the configuration of this spring. So I'll have a look at that. Okay, I got a crazy idea. While I was looking for some pliers, I thought I'd put the old spring of that other knife in there to see what would happen. And wow, the blade is really twisted and crooked, but I think the main thing is so it's not really flying open. I guess I don't have the pivot pin in right or something. It's just not. Just not working right. It's all cattywampus. So okay, that wasn't over far enough. There's the other half of the pivot wasn't over far enough. And it wasn't inside the hole, the pivot hole of this left liner. I don't advocate taking apart knives that have springs. The springs fly out and cause injury and blindness, and your dog will eat it and choke, and your baby will choke, and let Nuts on YouTube do it. There are many, many nuts on YouTube. You're engaged with one right now, so if you do it, wear safety glasses and prepare to lose parts. Just got to get in this slot here. The problem is that this has what's called a D nut, and if you've seen that little thing I wrote on Benchmade in the first book, you know what a D nut is, or D pin. It's a screw with a flat side on it, and then there's a sort of a flat side on the pivot hole. That's two have to match up, and the reason you have a D pin is that it won't turn when you try and tighten it up. So it's usually the left side of the knife has a screw that turns, and the right side will have the pin that won't. So I've got that in, I think. It's moving okay, but the spring's sticking out. So what I'm going to try and do is use that method and stick this down in here. This is the old spring. And see, I'm playing with this sharp blade, and this is dangerous. You know, and I'm pushing stuff and I'm forcing stuff, and there's risk of getting cut. So that's kind of in there. I'll tell you what, I'm just going to hold this with my hand. Ah, it works. And let's see if it assists us there. Well, I don't know. Something might still be off for binding here. Woo! Big click. I think I know why I heard a big click. Okay. So the spring likely popped out of the this milled out area for it. So I'll go ahead and give the proper spring a little bend. Maybe I can get the vector going above the pivot pin instead of below, and maybe it'll function properly. You probably can't see that. I'll do a close-up, but the way they made this knife is to me very peculiar, because the hole for the insertion of the hook of the spring is actually not only not in line with this hole here from the long axis of the knife, it should be over here, and they've got this nice long arcuate groove here for it to fit in, and yet the hole is way over here. It's actually below the axis of the pivot pin. It should be up here, and this spring should be pushing above the pivot pin, and instead it is actually a little bit below. So what I did was if it sits in here like that, I put a bow to it. So now it's bowed this way a little bit. And I don't want to overdo it, and because these springs are kind of thin, you could bend them without breaking. But that's not a hard and fast rule. They're hardened steel, and they could snap. Plus, putting a bend in them may put different stresses on. After opening and closing a couple dozen times, the spring may break. I don't know. Of course, it'll still be a functional tool pretty much in that it'll be a knife, basically a friction folder on the, well, it is a liner lock, but nope, there's no detent ball. So you'd have to be careful carrying that in your pocket a little bit. So I'm going to put this together, see how it goes. So I got this in, I got the blade a little bit loose, and we're going to see how it goes. Well, it's better. We got a little flipper here. And let me see here. Well, it's better. I didn't say it was good. Man, that was flying the blade open before. I don't know what the hell's wrong now. I guess the spring might be a little bit shortened. Well, I could now stretch this. And that is, if I stretch that, that's going to give it more forward force. And what the hell? Let me try that. Okay, here we go. If it don't work, don't blame me. This is a cheap ass knife, all right? But you said it was one of the better knives. Yeah, I know. Forget what I said, okay? Anyway, we'll see. So what I did, I opened up these loops a little bit. I also put a little more bend to this area, and we'll see here. No, it won't close. Anyway. Wait a minute. Something's out of kilter here. Something's out of kilter. Well, that is actually a little bit better. Of course, now it's not sticking. All right. Well, I could play with it even more. I'm getting bored. I put the safety on. Safety on. Here we go. Ready? Okay. Dilemma for this knife is that I think they didn't construct it the way they should. They should have put the hole further counterclockwise. I bent this so that it was kind of hitting against here and trying to push up. So in other words, it was coming in from this direction instead of that direction. That was why I bent it this way. But, okay. That kind of solved it, and let's move on to the next subject. All right, so I figure that it would be a good fix possibly to redo the attachment hole for the spring. It'll change the vector. So I went ahead and I drilled the hole. It took me about an hour. I'd use a cheap Harbor Freight drill, and I kept resharpening it about 20 times. I didn't want to waste a good drill. I did take a propane torch and heat it up and offer to soften it by normalizing it. It helped a little bit, but it still took me about an hour to get that hole in there. So you see where that is. And then compare this to, this should be a Chinese speed safe knockoff. So in other words, this is configured with the Kershaw type of Ken Onion patent design, and the spring is more like a bow. It doesn't have these squirrely-cues in it. So the configuration is a little bit different. This is the spring here from the throwaway knife. I put the other one back, and it just totally didn't fit, totally didn't work. It kept shooting out the side here, so I had to rebend it like 3 times, mainly just straightened out till it fit into the milled out area okay. And I already tried this, so it works. It doesn't work spectacular, but it works. So this is it. It'll close, and it'll close better than it did. And this is coming open, and it was locking. Now that locked. Okay, I give it a little extra flip with my finger, but not a whole lot. So it is fixed, repaired, and I think one of the issues was that the hole was too far in alignment, and it threw the vector off. And that's it. I think the design was okay, but it wasn't put together right, and even this is kind of unstable. So I think the spring should be bending. So if you guys ever decide to make a one of these spring type assisted openers, I don't know if this way would be that easier. You might need a lot of tweaking with this. I think I would go with the Kershaw way, but I don't know. A lot of them, well, at least I've seen a few made like this coming out of China. I haven't taken any apart from the U.S. That had this in it, but there may be some. So that's that. Okay, we're going to do one final tweaking here. I talk a lot about the theory of how these assisted openers should be working, and I thought, well, rather than just talk about it, I'll go through with it. So that's why I drilled a hole in there. Also, I was saying that I think the spring was a problem, and if we adjust the spring, then that'll solve a lot of that. So I played around with the spring. I opened some of these coils and put that in there, and there still seems to be a little bit of binding. It's probably now a little bit longer than it should be. I don't know. But I was saying that the reason, or I was at least thinking that the reason it wasn't staying closed was because now that the hole got moved further away from the back of the spring, that now the spring was too short. So I lengthened the spring a little bit, and you can see it'll hold that because it wants to pop out. The spring force is strong, and this handle configuration, it's not exactly flat here. It wasn't made that well. So you can see now that there's plenty of bias toward the closed position, and the blade's a bit off center, but yeah, the blade comes down closed all the way. So as far as it flying open, yeah, I can't flip it because it's so strong now. So I'm going to bring it out to here, and that did not achieve lockup, but that did. So it's probably a matter of getting in there and bending the spring so it doesn't bind on any of the sides and getting the length right, and it may fly open the way it should. Right. Yeah. But that, you guys should probably already know all this from the from book 1. We went over that extensively. Okay. That locked up. So that's it for assisted openers. I think part of the reason why they use this configuration is because I've never seen a patent on this spring. So I think this is an open design. They don't have to copy the Speed Safe by Kershaw and get sued. Although in terms of the physics, it is extremely similar, but the spring configuration is different. This may be a little bit easier to make, but it takes a little bit more of an adjustment to make sure it goes out of the factory working. So I hope we had some fun with that. These I picked up at the Blade Show because they were cheap, and also I wanted, of course, to compare these to the Malfunction Microtech and the other type of DAOTF that's floating around, and I'm sure it's going to look like one or the other. But curiously, the blade in this one seems to be offset only slightly from the middle, and it is a solid metal frame with some plastic handles. So I want to take a look at that and see how it's configured. I'm just curious that it may be configured a little bit differently, or the channels in here might be different. And this one is all molded plastic. And I wanted to, and they're obviously from the same factory. I mean, you can see. So I wanted to compare the manufacturer, how they made the channels and all. So let's take a look at these. Okay, here it is. This is the metal one. And you can see that this is basically identical in concept to the Malfunction Microtech knife. The manufacturer is a little bit different. Here are the catches here, the sort of flap valve catches, and the way they're milled in here is just a little bit different, and this allows for the handle to go on. Here's the blade. There is a slot here, a channel that the blade slides in. Here is the blade pin. Here is the spring hook and the slide carriage. Of course, look, when you ever mess with these, always unlock, you know, take the tension off of these things, you know. Like I said before, the way I used to undo them was I would pop them like that, but that's not necessary. You can just grab a hold like that, and then that'll unhook them. So anyway, but these things are dangerous. So here's the was it the Lightning or whatever? This one, that thing. This one has the spring out. Here's the spring hooks. Here's the slide carriage that fits on. Here's a channel, and you can see that he have the catches here on springs. And if I pull this out, then I can get the blade forward. So that's how that works. And as you'll watch that thing go back, and that's what locks the blade in the closed position. And then if you watch this spring hook here, it's on the spring catch is going to come up and grab the blade, just like that. And that locks that in. Of course, you got the blade hook that helps keep it from flying out of the knife, and also the spring hook catches on it. So this one, it's probably just this same metal idea, but it's got plastic around it. And you can see it's a little bit bigger and fatter, so I may play with that later. But basic design is the Microtech. I took a look at this knife at the Blade Show, and somebody said it was modeled after AK-47. If you see the resemblance, that's fine. I don't. But the thing that interested me is the guts were all external on the outside. The knife looks somewhat old because of the looks like a bone handle. And if I recall, this was not an automatic, although it has a button somewhat like a stiletto. And if you can see, there's it's sort of a glorified lockback with this slot here, and that slot fits up with that strange looking notch. It's got a couple like thumb bobs on there that are used to unlock the knife, and it's got that big spring in the back that biases it. You can see the button here. That's a lever, and it's got a forward notch on it that would unlock the knife. And it has the telltale hole there. That is the, well, that would be the notch, and the other part would be the latch. And there's sort of a telltale little rub mark, I think, right there that hits when the knife is closed, and then it enters the notch enters the latch. It's a top view, and you can see sort of this square latch that the knife is not in lockup yet, just about to. This is top view showing this big spring and sort of this sort of cantilever notch, and this is the belly of the knife. I think you can see in the back there's a view of that top spring, so there's no room for a leaf kick spring in there, so I don't recall it being automatic, and it looks like it's not. So it's kind of unusual knife. At least now you can say, if you ever see it again, that you've seen it once. So here is what would look like a pick lock, and that's basically what it is. But I talked about the NAVAJA in the first book, how the Spanish knife developed with the traditional 7 teeth, that it goes click, click, click when it opens. They call it a caraca. And I have not seen too many of those. But then I saw this, and this is basically a modern version. Now you look at the pick lock, but then at the top, this one has 4 teeth, and it's not arranged around the tang. It's just sort of in this long area that fits in this big slot in the latch. And you can see here that there is one large notch that actually locks up the blade. The other ones, when they roll over the end of the latch, they're going to make a noise. Instead of making 7 clicks, this one's going to make 4. You can see how there's a sawtooth angle, and it's angled back, so none of these teeth will actually lock the blade. It has to get all the way up to the final notch to unlock the blade. And here's a shot in the closed position. You can see the notch. Knives are very well made. Sort of interesting. So it was neat to see sort of this modern looking NAVAJA. Here's a different model made by the same guys. You could see that it is also a pick lock. This has the latch with a huge rectangular hole, but it's only got 1 tooth in it, and you can see how that locks up. Why they made it that way, I don't know, but it's a beautiful knife. It's kind of peculiar. And just for comparison, here's a traditional Italian pick lock. Now, this is very unusual because the guard is round, but the guard doesn't swivel, doesn't rotate. You have to actually use your fingernail to pick the lock up to unlock it. And this is how it looks in the half open position. You can see this has one sort of tooth in the tang, and it also has a slot between the front of that and the back of the tang, the way the knife locks up. So we see how the Italian stiletto gets open with a pick lock, but how do you make it a little bit easier? Well, use a German stiletto. Here is a automatic pick lock, so to speak, made by Walter, and it's got a lever on the side. You could see on the bottom the knife is closed. The mechanism is very similar to Italian stiletto. On top is the latch. Actually, the spring has a notch in it. It's the exact opposite of a lockback. And the blade has this pin. And when the blade is open, it locks up just the same as the Italian stiletto. Now, in the bottom of the ricasso, you can see a hole. That's the telltale notch for the release pin. You can see the gray button a little bit further back on top. Even further back, you can see a safety button. And here's a picture of a thumb being used to push the lever down, which will rotate clockwise, and that's going to push the spring with the notch hole in it up and unlock the knife. This is being done with the left hand because I'm holding the camera, but normally it would be the right hand. And this is another view of it. You can see how the back of the spring is coming up and the notch hole is coming off the latch pin. And here's a long view of the knife in the open position. You can see the safety button a little clearer. And beautiful knife. And this about almost open, with the blade being rotated down. When the blade is fully closed, that will load the spring and the knife will be ready to fire again. So it's a great looking knife. It's a great mechanism. This David Myers I was talking to at the Blade Show, and he's a guy who uses CNC to make his knives. And the interesting thing about him is not only does he make some really beautiful knives, but he says he uses CNC for the entire knife, even for the blade bevel. Couple things that he does is he routes out an area around the pivot pin to accept either a washer or the ball bearings, and in so doing he will get this very tight space between the liners and the blade. This is a shot of his knife, and you can barely get a feeler gauge in between there. And of course, his the tolerances are very tight. One thing that I talk about in the book is actually making these steel inserts to give a lot more wear resistance than just would be provided by the titanium liner. And one of the concepts was that it said that someday somebody will probably be making these inserts with different lengths so that it'll account for wear or account for fit up. Well, here's the guy, he's doing it. That's what he actually does. He's got these things labeled. He has a whole range of them, just some slightly longer than others. And when he fits up a knife, he will insert the proper length steel insert and get the optimum lockup. So he makes a very beautiful knife, and he apparently has a lot of YouTube videos explaining a lot of aspects of how he makes knives. He's very willing to share, and I suggest you go check him out if you haven't yet. It's more of the same of book two with a lot of different stuff like ballet song and all like that. So this is some of the technical info and some of the craziness that's out there. There's always going to be new mechanisms, so hopefully this will get you a start in how to look at knives and understand them. when you can't understand a knife mechanism, you're unhappy. So you shouldn't worry. Be happy. And this is a little book I wrote. You should read it quote for quote. Don't worry. Be happy, because it's all about fun of having the knowledge of what's in a knife. Thanks a lot.